Good. 3 halves times 5 halves. Now, when you're multiplying fractions, you can cancel before you multiply. Is there anything here to cancel, though? No. So what's 3 times 5? 15. What's 2 times 2? 4. So we get our 15/4. So you can leave it as an improper fraction. So that works with numbers. That's state change flip. But it also works with variable expressions or algebraic fractions. Can someone rename this using multiplication? Yeah, Benson?
A over B, and then times D over C.
Good. A over B times D over C. And are there any common factors to cancel out? Nope. So you just do A times D is AD, and B times C is BC. And that would be your final answer on that one. So this state change flip, it works a lot, doesn't it? Does it work for numeric fractions? Does it work for algebraic fractions? But the big question we have to ask, does it work for rational expressions?
Yes.
And the reason we can say yes, good confidence there, is because you know what this is? This is a rational expression. So is that, and that, and that. But it does get complicated as we deal with problems like example number 1. And this one is 2a over a plus 3 divided by a plus 7 over a plus 3. Okay. I said it still applies with rational expressions when you're dividing. Can we do state change flip? We can. And so what is it rewritten as? And by the way, on your papers, you don't have to write it the division way, then the multiplication way. You just look at it from your problem and go automatically to multiplication, which would be what on this problem? Wyatt?
2a and then over a plus 3 times a plus 3 over a plus 7.
Okay, and this is good review because did we do something like this yesterday?
Yes.
Okay, and it's going to help us with simplifying. Can I cancel anything before multiplying? And if so, what? Beth? A plus 3 and a plus 3. That's 1 over 1. Anything else cancel out? What about those A's? Oh, this is an addend, and that's a factor, and those don't cancel out. Fine. What's 2a times 1? 2a. What's 1 times a plus 7? And if you can't cancel it out anymore, then you're done with your answer. It works just the same way as it did with those numeric and algebraic fractions. You see how that goes? Okay. And hopefully, as you get to the third lesson, you're like, okay, I'm starting to see this a little bit better. How many of you are still kind of thinking that these can cancel out? Like you're kind of in the back of your mind thinking, why can't they just cancel out? If you have that struggle, that's understandable. But again, this is a factor that is an addend. So that's why it can't be canceled out. Okay, page 673, go to number 10. This lesson is not long, by the way. Hopefully you can get it done. For number 10, I need you to divide those two rational expressions on number 10. And when you get done, check with your neighbor or someone next to you or close to you if you don't have a neighbor directly next to you. And see what you guys got. And hopefully it's the same thing and it's good. You have an answer, Wyatt?
Yes.
Okay, first of all, Wyatt, give it to me in state change flip form.
X over x plus 7, and then times x plus 7 over x minus 7.
Okay, so stay, change, flip. Okay, Harper, anything cancel on this one? Oh, x plus 7, x plus 7. Ooh, does anything else cancel out? The x's?
No.
Sure about that? I'm ready to do it. I want to do it.
Don't do it.
Okay.
Dare you.
Somebody tell me why I can't do it because I really want to. Walker.
Because, well, -5 and x
Okay, these two are addends.
Plus -5.
Mhm.
And, yeah, it just doesn't work out.
Yeah, and maybe some of you are thinking, but Mr. A, can't you just say like plus 0? And now it's an addend? Okay, this is how I want you to think of it now to help you out. If you're like, I don't get this. Whenever you have a plus or minus sign in between terms, keep them as groups. Keep them as groups. So does this group cancel out with that factor or with that number? No, they are not common. Does this group cancel out with that group? Yes. So if they have a plus or minus sign, they are linked together. They have to stay together unless you can factor it out, which we'll see in our next example. Harper.
If it actually said like x plus 0, could you then pick up the
Well, so if I put here x plus 0, is this group the same as that group? No, and so we wouldn't be able to do it. So that's another way you could think of it. Keep them as groups. Yep.
Wouldn't it just help, like, with us if we just, like, substituted x with, like, 2 or something?
Put a number in for x.
Yeah, because, like, x by itself is 2,
Mhm.
and x minus 5, 2 minus 5 is -3.
So you get 2 over -3. Mm-hmm.
Yeah, and those can't be.
And if you just decide to do that, you would get, if x equals 2, you'd get 1 at -5, and those two are not equivalent. Yeah, that's a way to test out your theory on should they be canceled out or not. So good. Yeah, you can do that. Oh, there you go, x's. Okay, example number 2, back to page 671. Example number 2, they do get a little bit more complicated, but nothing beyond your capabilities. So I have 2m plus 6 over m plus 5 divided by m plus 3. I get this is a rational expression, it's a fraction, but that second number is not a fraction, is it? It is. Someone say change flip it for me, please. Wyatt, you've done so well with that. I'm going to have someone else. Ellie, stay change flip, please.
2m plus 6 over m plus 5 times 1 over m plus 3.
Okay. On all of these problems, factor everything you can from the numerators or denominators. So looking at this numerator up here, can anything be factored out? Or can this be written as a multiplication problem? What is it? GCF of 2, which will leave you as with m plus 3. And some of you are doing this on your work. I'm good with it. Like you write the factoring above it or below it. That's good. That's fine. Just don't get too cluttered up. That can make it kind of messy. Try to break it apart if you can. Okay, so all I did is I rewrote 2m plus 6 as 2 times m plus 3. Now are there any common factors? Yes, it's very clear. The m plus 3 and the m plus 3 gives you 1 over 1. Anything else? Okay, what's 2 times 1 times 1? 2? That's okay. What's m plus 5 times 1? Nothing else to cancel out. Yes, sir.
Well, let's say we have m plus 3, and then...
Like this?
Yeah.
Uh-huh.
Okay, so can't it be factored by 1, right? I mean, just that 1 from, like, m and 3 can be factored by
Okay, you could put a 1 here. If this wasn't here, right?
Yeah.
You got a 1 here? Mm-hmm.
So if you just keep doing that, and it would keep adding up to the... And it can get to, like, 5.
Oh, adding up? So, okay, you get your 1.
I mean, multiplying. Oh, you have to multiply.
And you'd be multiplying 1 times 1 times 1 times 1. You're like, I can't wait to get to 5. And you might be a while. But yeah, good. Hey, these are good questions. When you're asking me what if something can happen, I want to answer. I haven't heard that, but that's a good one to think. Wait, you might get to 5. Wait, no. You're multiplying. You can't get to 5. Perfect thought process. We're good with it. You're putting me to the test. It's 6 hours. My brain is already kind of mushy right now. I had a great lunch. Spaghetti. Gluten-free pasta. Yeah. Yes. Gotta have it that way. That's very good. Sorry?
Why does it need to be gluten-free?
It doesn't for you guys, I don't know, but I need to have it because of I have a sensitivity toward it. I feel better without it, by the way.
So if you had like normal spaghetti, you wouldn't be in as good as the mood?
Yeah, because I'd physically be hurting. I'd be like, oh, why did I do that? So one of the hardest things has been pizza. My favorite. My lifetime love. Has been pizza, and I can still have gluten-free pizza, which is awesome.
Wait, can you have Buffalo Wild Wings?
So I need to figure these things out.
Is Buffalo Wild Wings gluten-free?
Buffalo Wild Wings,
I think they have one, like...
they do have some gluten sauces, but the actual fryers, you got to ask if they're gluten-free or not. But they're pretty good.
Other foods that are like
That's why I instantly lost 10 pounds last year because of that. Instantly, boom, goodbye. Okay, can somebody rewrite this with state change flip? State change flip. Vivian, state change flip on this. Yeah, go ahead. Yeah.
5a plus 10 over a plus 5 times 1 over a plus 6.
Okay. Oh, the 5s can cancel out.
No.
Oh, I'm so no. Time out. I didn't mean that. I meant the A's. These A's. Oh, I want to cancel. Okay. Again, when I saw on the paper, I saw some work that showed that you're canceling those out. But I think now, after the third lesson, you're going to be able to say, no, don't do that, can't do it. But can I do something to this to make it able to be canceled? Good. 5 times 8 plus 2. Now this can cancel out. And what was your final answer, James?
2 over a plus, wait, hold on.
That's
5 over a plus 5.
That's right. Good recovery there, and that's the correct answer. Oh,
I was looking at algebra.
Wait, no, please. That's
you guys are so picky on stuff. And that's a good thing. Okay, example number 3. Just look back at the previous page here. Benson, can you read example number 3 for me, please?
Find x over x plus 2 divided by x squared over x squared plus 5x plus 6.
Okay. Here, it's easy to get overwhelmed, but I already know I could do one thing at least. If there's nothing else I could do stay, change, flip. And Beth, can you give me stay, change, flip on this one?
X over X plus 2 times X squared plus 5X plus 6 over X squared.
Okay, so that's something you can't do. And again, you can write that directly on your paper as a first step. Man, is there anything that can be factored? And if so, you need to factor it. Ellie?
The X squared plus 5X plus 6 can be
I'll
X,
cross it out.
X plus 2 and X plus 3.
X plus 2, X plus 3. Okay. So I factored x squared plus 5x plus 6 into these two binomials, allowing me now to cancel what? The x plus 2, which is very good. What else am I allowed to cancel out? Eli?
You can cancel that x and the exponent.
Yep. And so you're left with 1x there and 1 up there. And your final answer, Kendall.
X plus 3 over X.
X plus 3 over x. And then you can circle it. Okay. That's your answer. Oh, by the way, circle your answers. It makes it nice for me to grade it. Okay, but yeah, that's x plus 2 over x. Good job, guys. Okay, if you can do this next problem, you are very well set for doing well in this lesson. Go ahead, Beth.
Okay, so whenever you were getting the two
Binomials.
factors that add up to this.
Oh, yes. These two numbers?
Yes.
Mm-hmm.
And then you do like positive 6 and negative 1.
Okay, let's see it. So if I put 6 and 1 here, 6 times 1 is 6. That checks. But 6 plus 1 is 7. And we can't have that. But yeah, good question. Yeah, and what's cool about these is there's only one set of numbers that can get me multiplied to that and added to that on any of these. There's only one set. So
Is that like all numbers ever?
on those factoring, yes. Which is nice because you don't have to hope you get the easy pair or the hard pair. There's only one pair. Oh yeah, there's a lot of easy and hard way. Yeah, and actually it's cool. I'm teaching seventh graders about proportions, which you guys learned this year and last year. And you can make proportional problems very, very easy. I'm talking easy, like where you're just multiplying single digits, or you can do it where you're multiplying and then eventually dividing double or triple digit numbers, which, I mean, it's not impossible, and you can do. You might as well make your life easier. Number 13 on page 673. Again, if you could do number 13 toward the top, you're ready for this. In fact, I need 2 volunteers. One to work it out back in that board, and one to work it out on, sorry, you get limited space here. Taylor, you go back there, and you have a marker there, I think, and on this front board, Ellie, come work it out. Is this good?
Yeah.
Okay. And then everyone else can work it out, and I'll read the problem to you guys if you don't want to hold that book. So it's x squared plus 7x plus 12 all over, or divided by x plus 6. Sorry, over x plus 6. There you
Can we check in the back? See if we're-
Check with your neighbor if you wanted. Divided by x plus 3. And that's it, just x plus 3. All right, and then go ahead.
That is limited space. At least for Allie.
No, they're not. X plus 4 and then
Again, you can check with your neighbor, see how they did. Hopefully get the same answer. Hopefully it's correct. Okay, thank you, Ellie. Very pleased. The answer to number 13 is x plus 4 over x plus 6. Very good job, guys. All right, thank you. You guys get on these problems? I'm going to give you the homework. You have the rest of the time to work on it, and I will be here to answer questions.